Hello and welcome to episode 4 of Code Deep Dive with OpenTTD. In the last episodes, we went through the config initialization and reading various options, and then there was also reading of multi-language support. And I think we almost have went till the end of this thing, so I will continue where we left off. There are a couple of things which we should look into. There's some layout or initialization. Let's deep dive and see what's there. And here we see there's some ICU interaction. So ICU is actually external library. I'm not going to deep dive into here because, well, probably ICU deserves a separate playlist or at least episode of itself. There are some other initialization functions we will deep dive into. So reconsider game script language. Let's see what it is. Okay, so this is some game string data that's probably null. Okay, game strings. The currently loaded game strings. And game string is container for all the game strings. I'm not really sure what the game string is then. There are strings per language. Okay, so we have language strings here. How does it differ from what we had last time? We have simply the translations. Okay, it seems like there is some language reference and probably some mapping to the indexes in this language. Okay. Anyway, it seems that it was empty, so this function returns. Then we have initialize sorted cargo specs. So we go through town production cargoes, which is some kind of vector, I guess. Maybe let's check it here. Okay, so it's array of vectors, and each vector contain cargo specifications. The cargo specification tells us, okay, what the cargo is. So since the transport tycoon is about just picking cargoes from one place and delivering to the other, then it probably just describes what it is. And we have some such things like units here, sprites, even, okay, something about graphics, number of the sprite, okay. So some visualization reference. Also some colors related things. Okay. And it belongs to cargo spec structure. Okay, nice. So this is cleared apparently. Okay. And then the sorted specs are also cleared. But this seems to be empty. So we have cargo specification sorted alphabetically by name. Okay. And then we also can iterate. This is some static iteration, isn't it? Yeah. Okay, there is no cargo spec actually, so nothing to iterate. So I think since it's just empty, just nothing will really happen here. So all the instruction seems empty. Okay, so probably at this very initialization of the game, this doesn't do much. But since this is some general function, then maybe later when the data is present, it's invoked in some other situation, just to make sure that things are in the proper order. So then we have sort industry types. We can have a look. We have 240 industry types. Okay, that seems like a lot. So there are different types of kind of buildings or industries actually in the game, and each usually produce or accept different types of goods. And this is probably just, okay, there's an array. It holds maximum number of 240 types of industries. Okay. So there's some initialization of the indexes, and then there's some sorting by industry name type sorter. Okay, we can actually put a breakpoint here. Okay. Yeah. So we have industries type A, which is just an integer, I guess. And then we get the industry specification. So we assert it's in the range. And then from the specs, we just get the whole spec. Okay. Oh, okay. I did it too quickly. So actually we get the name of 2 industries, and okay, and this name is probably already translated. Okay, so we have get string, but it returns the string ID. Right. Can I see if it was returned? No. We can. So I would expect this string natural compare will tell us what it is. Yeah, here it is. So we have S1, undefined string, okay, and undefined string. Fine, so this is because there was no translation for a certain type. So not really a great example actually. But what we see is that this, first of all, it also collation. Okay, again, ICU. Not sure which that I want to get again deep dive into it. Maybe it's important for this particular comparison. What we need to probably understand is that in the end we just compare two UTF strings and we just say, okay, which one is if they are like the same, or how the ordering between them looks like. So since these are apparently the same strings, we get 0. So just the same order for both of them. Okay. So I think we can get back to here. And then we have build industries legend. Okay, so we have industry types. Again, this is just an index, and then we get a spec. Okay, so there's like a global, again, global spec variable that we can reference by indices. And the indices are sorted, but according to the name of the industry. That's how I read that. Okay, we check if this industry is enabled. I'm not sure if they're already enabled, so I will just leave the breakpoint here. And here in case nothing triggers here. Okay, no industry enabled. Maybe it will come later. Terminate the list. Okay, some terminator then. Region and color. Okay, we haven't seen that. Region and color. Okay, so this is probably in a game you have kind of a list that shows different types of industries, and then they're just colored. And this is probably the mapping that does that. And I believe we could just tamper with that to just print and like display it differently. What else? Build content type string list. Network content list window. Okay, something new. Can I see this? Oh, here. So this is the class. Window to list the content. That's the content server. Okay, quite a big thing here. But it seems that we just have this static thing here. Which is just an array. And this, oh, this is the enum, helper to mark the beginning of the types. So apparently at this position, we have some special strings. Let's iterate it a bit and see what happens here. So, okay, so I see strings, but I'm worried is that we won't see here. Yeah, so here's our pointer. Yeah, but we are not going to see everything here. All right. Let's move on then. Invalidate window class as data. Build vehicle window, train group window, road vehicle window. Okay. So this is some kind of constant, or enum actually. And this just represents vehicles and trains and different type of, different type of vehicles in general. So let's check one of these, how it behaves. Mark window data of all windows of a given class as invalid. So you have some window class here. and some data and UI scope. So I think this was the default. We just pass the class and then we do window iterate. Okay. Okay. Fine. Why don't I see iterate? Okay, I understand that this just is triggered by the loop. Oh, okay, because we see here that iterate is just all windows alias. So we just created all windows and then we iterate on this. Okay. It's fine. Tfront is false. I'm not sure what tfront is. Oh, it's the template parameter. So here it was false. Okay, all windows false. Iterate all windows in whatever order is easiest. So we return windows in iterator of z windows, and z windows is a global window list, which is a list of windows, the window pointers, and then we have a data structure for an open window. Okay, so right, standard list, and then what do we here? What do we have here? Okay, so this looks like a model class of kind of, you know, sub windows that you have in the game. And then obviously the state, probably if it's closed or minimized, dragging, sizing, okay, something like this. The class of the window. So for example, so the main one, status bar, and so on and so on. Probably kind of a type. And positions. So if I would guess, this is something that's used during rendering as a model class, just to know what to draw. Okay, and we have iterator that will just allow us to just go over the list somehow. Nice. Okay, so when the game haven't started yet, so there's no window. And I would assume this will behave the same. We're just checking against different classes, so this loop will not trigger. Okay, so we can exit eventually this read language pack. So we are good with that, and then we have some font cache. A function, let's see what it is. Okay, so this is some initialization of the font cache. Let's see, this is apparently some static thing. And again, we have some font size. Oh, that's clever, actually. It just allows us to enumerate. Oh, sorry, iterate over the enumeration using the indexes. So we just go with font cache and different font sizes. And we just assert that we don't go beyond a certain amount of font sizes. And then we have some caches here. Some standard array of unique pointers. Right, and for the given type, we can just or given font size actually, we can just get a font cache. And since it's not there, we'll just register the new one. And how does it work? We have some font provider manager that will try to load the font. Okay, so we can have many providers. Okay, this sounds flexible. And here we have some static providers ping. And there's some stuff in here. Okay, this provider, all right. That's interesting when to know when it was initialized actually. And then for each provider we try to load the font. So okay, so this is this type of provider. Okay, let's load. Let's see where we get to. Free type font cache factory. Okay, and then what does it do is that it checks the type, and just let's see how that was called. Okay, so font type was actually provided here and here. Okay, so there's some font type sprite. So it's bitmap sprites or the scalable true type fonts. And for this, we just load the sprites. Oh, okay. But this was loading only true types. So this provider is not interesting. And this one loads only sprites. All right. So we just create the sprint font cache, which is probably this one. So I will just put a breakpoint here. And from the cache, we just get the default height. And this is some array. Okay, some static array. 4 types of font heights. Okay, it's really 4. 1, 2, 3, 4. Okay, normal, small, large, and mono. Nice. So we have the size. In this case, it's 10. And then we have some scaling. Get default font height. Oh, there's also this one. Sorry, I just skipped that. And then we just take this 10 and there's some UI scale, which is some constant. Apparently. Okay. Scale traditional pixel dimensions to UI zoom level. Is it the same here? It looks like the same, yes? But we see there's different scaling. And we have a standard. Okay, so we've been here and here. Unscaled by zoom. Zoom base is 4. Again, some constant. Zoom base shift to underlying. Scans to enum. No, from enum actually. From enum, and it returns the number. Okay. Okay, and we get from zoom level. Oh, okay. Are possible zoom levels. So it looks like depending on we zoom things, we have some like limited options to do that, and then it somehow impacts the fonts. We get value 40 here. Okay, let's see what's returned here. Oh, okay. Okay. So it was 10, I guess. Then, so this gets 0. Scale traditional pixel dimensions to font zoom level for drawing sprite fonts. So maybe it somehow to differentiate. Okay, a bit hard to decode this. I also don't remember really how this scaling works here and why it is important. Maybe we need to just trigger example in a game later and just see how it impacts this fragment. In any way, we just get a pointer for this particular font, and it's apparently it just registered here. Oh, I think I just skipped that. Let's see. Yeah. So once we have a font cache, we just receive the size. We get the reference to the cache, global cache. And we move it to the parent. And parent, for some reason, it can just get, somehow it's hierarchical. Font cache, okay. Oh, and we move it back. We move it back here as well. Okay. Okay, so probably we can, so for each different type of font size, we just get different fonts, like, because different sprites needs to be loaded so that it displays properly. And then these are registered in this font cache that we got. And the layout here, I think what's important here is that they form kind of a parent-like structure, like child and parent, and then like the child replaces parent in the cache, but there is still reference that's being held. Okay, so the initialization is done, and then we go through all the font sizes, and we reset the font cache. What does it mean here? So we have a fonts, which is font color map, text color to font. Yeah, and okay, and font is simply the font cache. It's a bit misleading, I guess, because it says font cache, but it seems like it's really a font. Like conceptually, it's not just cache for fonts. It's like usually the sprites or whatever we use start here, and then we just say, okay, font is the reference to this cache, and then but we also say it's color and okay, so maybe also size here. So I would assume that we may have different font objects with one cache, with the same cache reference for each, and then different font sizes, and then we read from this font cache on the sprites for different size. That's how I would understand that. Anyway, we do the clear here. Just to be clear, this is just the map. But it seems this map should be over the text color. So why do we put the font size here? Am I reading it correctly? Oh, okay, because here I just focus on this type here. That's a map, and we probably clear the map. It's not, we don't clear we clear the map. It's just that we access it, the array first, and that's what we index here. And that's fine. So and then there's some line cache. Is it again some global thing? Cache of paragraph layout lines. Okay. Line cache. Size limited cache with a least recently used eviction strategy. Okay, so some helper. So helper class that helps us work with line caches. Font state. Okay, I think we'll get to that. This initialization doesn't tell that much about how it's going to be used. So, like, I feel it's nice to just go over the structure, to just create some mental vision of what's going to be there, but exactly what it means and what will happen with that, I don't know yet. We'll need to wait for some action, probably. And here we just load the font again, but this is the true type font. So of file size normal, and then we just register that. Okay, and another font size. We just go over the all font sizes. Okay, so we're done with fonts, I believe. And then here's something about windowing system. Okay, initialization of windowing system. iConsole close first. So we have iConsole mode. In-game console is open, whole screen. In-game console is closed. So apparently there's some console that can be used, but I don't think it's opened. Can go over that. And then we have some, I believe the underscores is for global variables mostly here. So we see there's some focus window, mouse over last window, window of the last one, mouse over event. Okay, so all this stuff is just set to null, meaning that we have nothing. Scrolling viewport, mouse hovering. Okay, and then set up widget dimensions. Set up prescaled version of widget dimension. Okay, so it seems like a long list of statements that will just set up this global variable. What is it? Widget dimensions. Okay, padding around image button image. Padding inside inset container. Sticky box. All the paddings. Padding dimension to apply to each side of a rectangle. Nice, some helper structure apparently. Close box. Resize box. Debug box. So I assume that for we have a window, we have a widget, and then there will be different dimensions of these widgets and probably paddings as well. So for example, there will be like a kind of a close marker that would need some padding. And this is stored in this scaled thing. And then we just have the scale GUI thread, which will scale these paddings to GUI's zoom level. So perhaps the padding depends on the zoom level. Yeah, that makes sense. And then we just use the scaling that we have seen before. If this value is greater, or perhaps this UI scale actually is different, then we'll just get it rescaled. It's probably not the case here, so I would imagine we just get the same value here. Actually, the padding is 0 all the way down. That's how it looks. Oh, here is kind of different. Oh, because it's unscaled. Sorry, I haven't read that properly. I thought it's just, yeah, it wouldn't make sense to just run the function over the same attribute. Okay, can I look here? Okay, the one-to-one. Yes, so there's no real scaling. And then invalidate dimension cache, reset cached sizes of several widgets. So shadebox dimension. Okay, so dimension is dimension, width and height. Some helper function. And then what's that? This is some glyph widget class. So it sounds like the representation of specific things that we can interact with. Okay, so just zero them out. And then for scroll bars, I would assume it's similar. Init depot window block sizes. Set the size of the blocks in the window so we can be sure that they are big enough for the vehicle sprites in the current games. Okay. So we have different types of vehicles here, and then we just go over each one. And what's that? Engine. All right, what's this class about? It sounds quite serious. Oh, it's like engine, like locomotive engine, probably. But the list is empty for this at least. Okay. So I would think that all these scaling things will be used a bit later, and this initialization may be not that clear without having this perspective. So I will just skip that until we just go to the rendering of Windows. And for now, I will just leave it as it is. So I think the important thing to understand is just that there are all these initialization functions that for each type of different windows just set up some offsets, some paddings, some of this kind of stuff. Default vehicle width. So it sounds like, yeah, the width of a vehicle, probably in pixels. And then we iterate. Okay, let's see what we iterate over. Okay, there's nothing. Still nothing for the engine. So maybe it's not about the engine types, it's just engine objects that we don't really have. So, and that was it for the depot window block sizes. And then there's show first error. We say that the window system is initialized, and if there were some errors, we show that, but no errors, so nothing to show. Okay, so let's exit that. So we have passed the init window system, and then we have some find set of the base graphics. And okay, we will scan for some files. So we have file scanner here. All right, base media. Oh, this is actually subclass of the file scanner that we have seen. So we will just scan for OBG. And then, okay, so we'll scan for OBG, and this time, since we know this function, let's exit. Oh, a lot of this. Yeah, we'll be just adding the files, but this time what's important, we're not scanning for tar files, but I think we just we will scan inside the tar files. That's the difference. Do I have it here? No. So we know this function from the previous episodes. It will just look up for the files of a specific extension, and we'll just add it to the file scanner. So we can skip to that. Okay, and we have tars enable, and there's some old data there. And then we don't have the, oh, the tar list was empty. That's interesting. Huh. I was almost sure that, oh, because the directory with the old data there was empty. Okay, so maybe I'll leave a breakpoint here. I wouldn't expect that we'll find somewhere here. So, and then, yes, we are now scanning for a base set. And then we search in tars as well. Okay, so let's give it a go. Yeah, and here we are scanning the tar files, because as we remember, there exists this one of them. Should we have it here? So there's file scanner. No. If matches extension, tar first. Okay, and the tar is here. It's a tuple. Oh, where is it defined? It's here. Tar file list. Okay, so you remember this, like the map for the entries, and then we'll just check. We'll have matched extensions, which for not empty extension and find them longer than extension. We will just take a view, and it will just, yeah, it will just look up if the final 4 characters match. And then it means that the extension has a match, and then we'll just add the tar file name here. Okay, it probably didn't match in this case because the add file was not triggered. Can I have it here? Okay, so probably, okay, there's a number is free, so something was scanned. Okay. So we found like 3 sets. But the graphic set is empty. And then this short name is not empty. Or was it a number? It's actually it's a unique key for the set name, for the graphic set name. Okay. So we should have the valid graphic data set and then the name. Oh, okay, I skip it, but it just set. All right, it just picks up the base media set depending on some number. Okay. Oh, and then so valid graphic set was true, but the extra params were empty. Okay, so and this was apparently false, so the key was, I think, here, because we just set this name, or actually set the set by the short name. Okay, and then we have initialization of game palette. Let's have a look. Okay, we have a lock. There's some global mutex. We have a guard, and then the palette is set to. Okay, there's some static palette, and we have a colors here. So each color is like a. Okay, it's an alias, and we have conditional trait here. If we have a little Indian as a native, then I believe we will pick this one, BGRI. And for the other, it will be just this. And then we have a union where you can represent it as a number of just a single RGPA or BGRI, depending on the sequence. And here's the encoding. What's M? It's probably just a, yeah, just a kind of abbreviation. So we have just a palette of all the colors that we want to use by default. And apparently we can just switch that. There's like a current palette, and there's just some static palette that it's actually DOS-based palette. Okay, so historic one. So probably if we just want to hack this out, then we can just change it directly here. And then we have this do palette animations. And this is a recursive mutex, so we can lock it twice in the same thread. And what is happening here? Animation counter for the palette animation. Okay, get current blitter. So we have some global blitter, I believe. By default is static thing. It's unique pointer, but it's null pointer unless it was set before. Was it set before? Oh, I really need that to be set. That's a pretty printing, but okay, it was null pointer, definitely. So we just get that. Oh, okay, it's just not. Huh, interesting. Okay, so really in need of pretty printing. So we have sprite encoder as a blitter. And then there's also some extra palette values, which is, yeah, just yet another set of colors and that we can use. Okay, some counter. So we don't have an empty blitter, and there's some palette animation. Oh, so okay. So, but it's apparently not none, so it's not triggered here. So it doesn't mean that we can just animate the palette somehow. Probably yes. Makes a copy of current animation palette. Yeah, so is it like that we can animate palette, or is it palette of animations? Or for animations? Okay, we will see probably soon. A few values that are related to animations using palette changes. Number of animated colors. Make a copy of the current animation palette in old vault, so the work on the current palette could be compared. See if there has been any changes. Okay. Fizzy drink bubbles animation. Suddenly some fizzy drink animation. What's that, Evie? Okay, extrapolate the values. Some specific code to some fizzy drink. Hard to tell. Oil refinery fire animation. Radio tower blinking. Okay. Palette position. So basically take this fizzy drink, which is just a color, a set of colors, fizzy drinks, like here. And then this palette position, we just apply this. Okay, so this is some complex stuff that I cannot really understand, like without like deep diving really into this palette stuff. So how I understand is that okay, this is just my assumption that some certain things in the game are assigned the color from the palette, but maybe some positions can swap or change the colors frequently to a small blinking, maybe. Hard to tell if that's true exactly. But also without like knowing really how the color is used, it's also difficult to understand. Why do we do all these things here? Like this. So length of the glittery water animation. So it doesn't mean that we just encode all 15 colors here and we just assign it for whatever reason. And why here is we add 3 here. So maybe because of which color component it changes. I'm not really sure. Right. Okay, let's exit this function for now. Okay, so here is like blitter loading section, and I think quite a bit of things related to loading graphics. So probably this will be nice block to start with the next episode. I hope you'll like it and you'll just join me next time and we'll just discover what's here and how it works. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.